Okay, so now as we look at the PET is called the project evaluation and review technique. And then of course we have the CPM, which is for critical path method. First part of it is called project evaluation and review technique. So in PET, we look at finding the expected project activity, how long is it taking for an activity to be completed. Then, of course, we also look at the time taken to finish working on a project. Right, so now getting down to PET, we have the activity being drawn. It is activity on arrow or an activity not. So there's an activity on arrow or activity on not. So in particular, we also look at an assignment, question from an assignment. For an example here, we look at the, here we have activity A starting. So meaning that B can only start when A has been done. Also now, activity C and D can start when B has been completed. That's when we can have activity C and activity D that can be done only when B has been done. And then activity E can take place when C and D have been completed. Activity E can be done when F and G have been completed. Then activity I can be completed when F and G have been completed. Right, so now getting down to the assignment. Before getting to this assignment, we have the formula for PET. So the for PET formula, okay, so when getting down to the expected project completion time, we have the formula that we use for the project, calculating the project duration. Okay, so now when getting the project completion time, we have the formula here. Here we say project completion time in PET, we say the time expected, which is the TE, time expected is equal to, formula is equal to O, which is optimistic time, as then 4 ml, and plus the pessimistic time, and you divide by 6. This is the formula to use in getting the time expected. So from this assignment, they needed the missing figures, like to find the time expected for activity A, the time expected for activity H, and also the time expected for activity J. These can be found by using the formula here, where we know this is the optimistic time, the O is optimistic, and we have the other one, which is P is for pessimistic. So this is the pessimistic time. So you have this one as pessimistic. Then the ML is the most likely. So ML means most likely. So you just need to substitute and get the figures that we need. So depending on what has been given, we can use the same formula to manipulate, substitute the values in this formula in the project evaluation and review technique for us to get the figures that are there. All right, before we get into the Gantt chart. So how to get the three there, you can just use one example here to get the figure there, which is a 3. So for activity A, we can use even from this table here, you can find how they obtained a 3. So for activity A, if we know we have been given, even here can be done for activity A. Okay. Right then, so using the formula concerning it, yeah, this one, we can also use this one where this O represents optimistic time. And then we have L, this one is optimistic. And we have a P is pessimistic time. This is pessimistic. This one is, and then the other one is most likely time. So this one is most likely. So we have the most likely. So we just need to substitute and get whatever we need. So for activity A, we found the 3 by substituting. The 4 is a constant number. So these two are constant, they're part of the formula. So we have a 4 and the 6, these are constant. So from here, we can now try to get whatever we need. So for activity A, we found a 3. Activity B, it was already given. So we're checking and activity B was already sorted out in the question paper. Then even activity C was already given. Activity D was already given. Activity E was already given. Activity F was already given. Activity G was already given. And activity I was already given. So these ones that were given, no need to use the formula to get the TE, the time expected. Now, the other ones that were not given, like activity A, had to use the formula to find that. And activity H was not given, and activity I was not given. So there was need to use the formula to calculate that. So for activity A, we got a 3 because the other figures were given. We had the most likely was given, optimistic time was given, pessimistic time was given. So there was need to just substitute to get a value. So we got a 3 for activity A. Then the other figures that were not given, just making the substitute formula, cross multiply, like for B, try to cross multiply, get a pessimistic time that was not given for activity B. Activity B, the pessimistic time was not given. We're just using that formula to maneuver, to just use it to manipulate and so solving for whatever was actually needed. So for B, we had 3 for pessimistic time, and then the other one And so meaning for D, we were given. Okay, so D we are given. But we just need to get for D. We're supposed to get D, the time expected was 5. So it needed us to find the other value, which is optimistic time that they needed for D. We found it 4 using the formula here. And getting to the other ones here. Okay, so we can get from here, from this document, that we find for C, the time expected was given. So there was need to find the other, which was most likely time. So this one was 2.05. Then for D, they are given time expected. So substituting here to find the most optimistic time, which was 4. So just using the formula for page where you have the optimistic time, the most likely, and the pessimistic, we're able to find whatever we need. The time expected for E was given as 4, and they needed to find the most likely, which was 4. That was for activity E. Just getting down to F, needed a pessimistic time, meaning a time expected was given, and then most likely was given, the optimistic time was given. This is optimistic, the most likely was given. The 4 and 6, these are constant, and this is the time expected. So meaning we can find the pessimistic time, which is this P, which was 4. Getting down to the G, time expected was given. So substituting here, we are getting the optimistic time, which was 1.2. And getting down to the other one, which is the time expected for H, we found 4.17, or time expected was 4.2, rounding off to 2 decimal places. And for I, the time expected was given. They needed the most likely. So we can find, we can solve for most likely here. So we got 4. And for J, they needed a time expected, meaning all these were given, the optimistic, the most likely, and the pessimistic. These were given. We needed to get time expected. So now the page diagram can be drawn. Here we have, after getting down whatever we need here, we can draw
put together. Is anyone understanding how the missing figures are calculated?
Yeah.
Yes, but just a question. Just a question on the second last calculation. I think it was on. Is it maybe just scroll up a bit? Okay. Yeah, right here. When finding how do you make the subject of the formula? I want to see just down there where we are finding the most likely. Down there where we've just written M.
Okay, all right then. So now here, how will we get the most likely? We are trying to make the subject formula. So this one, the time expected was given as 4. This 4 is same as 4 over 1. So when we cross multiplying, we're going to have a 6 and a 4, which is here. And what we are saying is a 3 and a 5 can be added there to give us 8. This is where the 8 is coming from. 4 and 6, we are getting 24. In this 3 and 5, we are getting the total of 8. Then the 4x is constant, will just be like that. We can push a 8 the other side. So this is 24 minus 8, which is equal to 4x. We are solving for x there, right?
Okay.
So 4 and 6, I'm sure you can see that giving us 24. And a 3 and a 5 added, we give us 8. We can push the 8 the other side. So after crossing the equal sign, we are getting a negative. So we are getting 16 here, which is equal to 4x. Now we can divide by 4 both sides. Now we are getting our x as 4. This is where the 4 came from.
Okay. All right. Thank you. Understood.
All right then. So after getting to this one, we can now, since we have gotten whatever we need, so we have expected times are the ones that we use. So in short, what we're trying to say is that for each activity, like activity A, it's taking approximately, if we're talking about weeks, we are taking 3 weeks for it to be completed. In activity B, we are taking from here, we can see, okay, so we can see from here, we can see that A is taking 3 on average. These are in weeks. So A is taking 3 weeks, B is taking 2 weeks, C is taking 2.2 weeks to be completed, D is taking 5 weeks, E is taking 4 weeks, F is taking 3 weeks to be completed. They have given us these are in weeks. And then each of these ones with in weeks. So if you're constructing a house, maybe the foundation is taking 3 weeks. Okay, so each of these activities, we have gotten them in weeks using the formula here for the expected time. And then after that, after we have come up with the expected project duration for each activity, then we can construct the network diagram. From here, because the question requires that we calculate the missing points, which we have done for part A, using this information in the table here. Then we can now get to the PET network diagram. So we can either use an activity on node and then or activity on arrow. So depending, but this is an open way, the examiner will not give you unless they specify, but we have activity on node, activity on arrow. Now, we can come to this precedence information here. Okay, so what we're trying to say is that with this one, activity A is a starting activity, meaning that there's no other activity that can take place before activity A starts. Right, so there's no activity that can take place before activity A starts. So meaning activity A is a starting activity. So meaning as we come here, we are going to simply say activity A has started. So you have this is activity A. After A has started, we can have activities that are taking place here. Okay. So the activities that are taking place after activity A, we have so after A, we have B and there is a C. So after A has completed, there is activity B that should follow. So we have activity B here and C. So these they should take place when A has completed. Now, after A has completed, there is B and C. You can see B and activity C there. Now, after B has completed, let's check out what is happening. After B, there is a D. So there is a D. Okay, so after that one, there is a E. So the D, even it come this way, you can have a D here. So there is a D here. And also there is a E. So you have also E here. So this is it after activity B has completed. So we have active is E there. Then what next? You can see then after E. Okay, so here we are done with these up to there. Then after C there is F. So after C there is a F that is coming here. Okay, so we have F there. Okay, so we have F. Now here we can see that after, so here this one has also been sorted out. After D there is G. So here there is a G after D. So after D has been completed, there is a G. Okay. Then we have the other one. The other one here, which is after E. So after D, there is G, right? Now, after E, F, and G. After E, F, and G. After E, F, and G. After these ones have been completed, there is an activity that is taking place here. So after E, F, and G, so after E, F, and G, when this is three complete, that's when H can only begin. So after you have done all these three activities, is it activity H to take place. So this is what is happening here. So that's in line to explain this diagram here. So after E, G, and F, after these three, E, F, G, after E, F, and G have completed, there is H. Okay, then after H is I. After H, there is I. Okay, so there is I there. Then after I, there is J. After I, we have a J. So meaning J is the ending activity. So this is how this network diagram for the PET for part B is supposed to be drawn. All right. So after I, there is after H has completed this I, then after I is a J. So from here, we can now get to the figures that we have computed here to put. Okay, so now the figures we can put here. This diagram.
I have a question before you proceed.
Yes.
Okay, so this one is the one for nodes.
Yeah, so this is
Or
yes, activity on node. These ones are called node. So this is a node. Then this is also a node. Okay, so we can also do the other one. We have activity on arrow. Okay. So activity on arrow is done this way. All right. So activity on arrow, if it is need to be activity on arrow can be drawn in this way, where we have here. So this is an activity on arrow. So when A has completed, that's when B and C can be drawn. Can be that's when they can start. This is activity on arrow. This is activity on arrow. So this is what we have as activity on arrow. And then the other one, so this is an arrow, this is an arrow, this is an arrow, this is an arrow. These are arrows. So we are putting activities on arrows. So it's open. The PET network is given by, so here we have activity on arrow, or you can have activity on node, depending. So this is the activity on arrow. It can be activity on a node like this one. Yes, is that a question again?
yes, I understand.
Okay.
Okay, so are we conversant with how to draw network before we proceed?
I think I have a problem on knowing which one comes first and where it ends. If you can go back to that diagram which is showing the letters.
Okay.
The actual question.
Okay, so this okay, the actual question.
Yes, here.
So,
which ones are you looking at as in having the starting point? Is it the first letters or the second letters?
Okay, that's a good question. So now here, if you see at the first one here, there is a dash. It means that
Yes.
it means that for you to start working on this project, activity A was a starting activity, like the foundation when you're building a house. Meaning that before you do anything, you're supposed to do a foundation. So there's no predecessor. When you talk about the predecessor, we're talking about activities that could have been done before the proceeding activities. So preceding means activity that was done before the other one.
For the other one. Okay.
Yeah, so meaning at activity A, there was no activity that was done before activity A.
Okay.
So there's a.
So what if there was a letter there?
Yes, like so. Meaning, if you can see the second component here, it means that activity A was done before B. So B was a.
B.
So B was a following activity, followed after A completed.
Oh, okay.
So meaning that after A completed, that's when B started, and at the same time, when after A completed, that's when also C started.
Okay, so the way it is like here, there's AA, it means B and C are coming from A.
Correct.
Okay. Then
yes.
D and E are coming from B.
Correct. So that's why you are saying here
Gotcha.
A, B and C are coming from A. Then again, when you come here, we are saying D and E are coming from B. You're coming, so from B there is D and E.
Okay. Okay.
And then, got you. And then F is coming from where?
C.
From C. So F is coming from C. Then it was and then what about G? D is coming from D. D, that one. So meaning that G is coming from D. D is coming from D. And then we have this combination here. E, F, G. So E, F, G, after these activities.
Yeah, they meet, that's where H starts.
Correct. So meaning that after E, D, and H, where they have done, that's when H can only start.
Okay.
And then after H, there is I.
Okay.
And then
I'm clear now. We can proceed.
All right, then. So we have after that, now we get to what the question is about. So here we wanted to find what? Wanted to find the page diagram that's been drawn, the missing figures. I'm sure are clear. And then after this, we are supposed to determine all the path, the critical path, and the total duration of the project. All right. Now, meaning that here we are supposed to find the various routes. So the first one, we can go from A, we can go this way, A to B to D to G to H to I to. So we have the various routes here. So we can move from A, we go to B, okay? Then to D, then we can go to G, and we can go to H, and you can go to I, and you can go to J. That is it. We are looking at part C. Okay, so part C of this problem, which is this one here. So we have that option. So that is determining all the paths. So the other one, you can go from A to what? A to B. So A to B. After B to E. After E Okay, after E, we can go for H. After H, we can go for I. After I, we can go J. This is it. What goes on. And they have another one. You can say A going to C, C to E. And after E, we can go to H. Then H, we can go to
F. F. You've skipped F.
Okay, so there is, this is it. This is F, A to C to F.
Yes.
A to C to F. This one here is F. A to C to F, H, then getting down to I, and then the last one is J. So after this, we can now find which one will give us the critical path. The critical path is always the longest path. So this is how we actually find the virus roots. Okay, so on the virus roots, we are getting these ones. So here we are getting from the virus roots, we have these ones that are actually given here. So from here, we have the A to B to, according to whatever we have found here. So we're supposed to find what is our longest path. The critical path means the longest path. So here we can come and get it. So critical path and the duration. So we have here, we can just, these figures, they're coming from the duration for each activity. Like from, can get this one from the ones we have already computed from the network diagram. So the ones that are given, looking at the network diagram. Okay, so here we can start aggregating. This is activity or node. And then so here we can start getting from here. Activity A, it took 3, so just substituting there. So we are getting, these are coming from the various duration for each in order the way they are, the respective order, the way they are. So we have this one for this activity, for this path, we have 21.9 weeks. Then getting down to the other one is 18.7. Then the other one is 17.9 weeks. So here the critical path is the longest path. So we are saying we are taking 21.9 weeks for this project to be completed. Because the question here is asking us, how many days or weeks are we taking? So we are getting 21.9 weeks for this project to be completed. All right. So from here.
When summing up the numbers, we are using the total expected time, right?
Yes, we are using the expected time for us to come up with the project duration. So we are using the TE, the expected time that we are from the table here. Okay, so the expected time. Okay, just a minute. So we are getting the expected time. Okay, so expected time from the question, the expected time. Okay. Okay, so we are getting the expected time. This column here is what we are using to substitute in the network diagram for us to find the total project duration. So here we are simply saying this project is taking, so from the network diagram, we're using the text. So here we are getting the 21.9, okay, on the critical path. So we're getting the 21.9 weeks. Those are number of weeks that are needed according to a critical path, the longest path that we have. All right. So among these, The first path we had 18.7 weeks. The other one is 21.9 weeks. The other one is 17.9 weeks. So among the various routes that we have to check the one with the longest path. All right. Is that clear?
Yes, yes.
Okay, so now after that we get into the limitations according to this question. What are the limitations of the Gantt chart as a planning tool? So the Gantt chart depends on the project duration, so it cannot be computed without this. So those are the theoretical parts that we talked about, as we said. So here it can be complex or it can be time consuming, especially for a long project or a bigger project. It can be cumbersome to come up with. Okay, it's time consuming. It becomes this one was the first one, time consuming. Okay, it's complex to be obtained. Okay, so just about that. Of course, there are other additions that can be there. Okay, as we look at the limitations here. Okay, so the Gantt chart relies upon the work breakdown structure to have already been constructed and for it to be completed or to be complete. So without the project duration, the Gantt chart cannot be drawn. Okay. All right. So of course you can go for any other limitations. All right. So now we can get down to the second part of this problem. So the second part here was to do with the part C. So I'm sure the first part has been answered. Part B of this problem has been sorted out. All right, where we're looking at finding missing past the paired network diagram, the critical path, and the total duration, where we look at the longest path, and we've talked about the limitations. Of course, we can go for another. All right, and then we have now this one, the second part, where we are looking at preparing the job installation on IT system at Banner Bank Zambia Limited. And they have given us a duration from 0804 8th April 2022 to 20th May 2022. All right. Now, the next question, the first activity here, we have the activity and the week and the number of work days. So for activity A, we have the design system on the computer. Then the second part is we're taking 1 week actually. The design system on the computer will take 1 week. A number of work days, you have 5. Then we have the purchase of components, which is we have to find what week. But we are taking 3 days when purchasing the component. Then on this one, I need to be a little bit slow because you need to understand it thoroughly. Then the third part for activity C, we are going to configure the network. We need to find the week, which week are we going to configure network? And then the other one, prepare the software. And then you don't know what's the number of work days are given. You have to install the software. Don't know in which week are we going to install the software. Then we're going to assemble the computers. We don't know. There's a question mark there. We are going to connect computers. We don't know in which week we are going to do that. We're going to pilot test and refine system. We don't know in which week we are going to do that. But number of work days given. Then you start up the system. Then you inaugurate and hand over to clients. We don't know in which week. The number of work days is 1. From the data given, the same, prepare or draw a full Gantt chart at the end of week 5. The second one is after you calculate the missing numbers, then indicate the completed and planned activities on the chart, then explain the shortcomings of the Gantt chart as a planning tool. All right, so let us start with the first one where we're going to look at preparing or drawing the full Gantt chart. Of course, we have week 1, we are designing system on the computer. We're taking 5 days, but we can make an assumption. Every organization, working days are from Monday to Friday. So we can take it that way. As long as an assumption has been there, we put an assumption that we only work during the week, Monday to Friday. So meaning other days, company not doing anything, they're not working. So a day design system on the computer, taking 5 days, and it's in week 1, right? So as we come to the Gantt chart, we can use both ways. So here, design system on the computer, it's done in week 1. Okay, of course, the week has 7 days, but we have only working 5 days here. So this is a guiding factor. That 5 days is our guiding factor that they're not working the other days, unless they had put the 7 here. We haven't seen any day here beyond 5. So that's why we have an assumption that they're only working from Monday to Friday. We are the number
Actually,
beyond.
I think the lecture even clarified that we should just consider 5 days.
Okay, all right, then that's okay. So that's the way the maximum 5 days is there. So now let us get into analysis, full analysis of what is happening here. So you can see, assuming that's 5 working week. So meaning for designing a system on the computer, we are only taking, so it's 5, so it's done in week 1. Okay, so it's done in week 1. So these are number of days, 1, 2, 3, 4, up to 5 days. That's why we have shaded this part. Okay, so similarly, as we get to this other document, benefit as on the flip side. So we are saying this is Saturday and Sunday. So meaning from here there up to there, 5 days, meaning that so meaning it is this one representing Saturday and Sunday. So even this one is representing Saturday and Sunday. This one is representing Saturday and Sunday. So and also representing that we are not working, we're not doing anything Saturday and Sunday, Saturday and Sunday. Okay, so we can even do it unwritten one. So design system on the computer, 5 days. Now, after we have design system on the computer, that's when only the purchase of components can be done. Okay, so meaning this is in week 1. So meaning this will be done in week 2. So this is where this one came from. So in week 2, so this is where we have these weeks. Okay, so this one can only be done in week 2. Purchase of components can be done in week 2. On Saturday and Sunday, here, this is Saturday and Sunday, here we are not doing anything. The blue line here, columns, they represent Saturday and Sunday. So we're not doing anything there. So now, rest of the components can be done in week 2. So week 1 has already ended. So in week 2, we can now purchase of components, but taking how many days? So we can go for number of days here. It has been given 3. So we have 3 days there, all right? So from here, we can start counting. So it will be done on 8th, 9th, and 10th because of the 3 days that has been given already here. So we have 3 days here ending at this point. Now, after we have purchased components, that's when we can now configure network, all right? So we can now configure the network. It's taking 2 days. So let us see if it is within the same week. Okay, so let's check because the week is ending. So here, from here to here, meaning this is Monday, Tuesday, Wednesday, all right, for purchase of components. So meaning this one can also be done because it's taking 2 days. So it's within the same week, second week. So that's where this one, we can come and put it week 2. All right. I don't know if people are following.
Yes, we
It's making sense.
Yeah, so that is done in week 2 because it's 3 days, so it's within the same week. So within the same week. So here we have 1, 2, 3, 4 up to 5. You can count 8, 9, 10, 11, 12. This is second week. We have exhausted these purchase of components and configure network. So Saturday and Sunday we are skipping. We are not working. Okay. So we can now go for the other one. Okay. So the other one, what is happening is we can now go for prepare software. So when preparing software, we are getting it's 2 days. Okay, it is 2 days. So let's check where the 2 days will be. So 2 days here on preparing software, it's only 2 days. So 2 days we are ending. So we are just doing Monday and what? Monday and Tuesday. So in that week, so this is week 3 now. Okay, so also prepare software is week 3. So that's where you are putting week 3 here. So that's where the 3 is coming from. Then what else? Let us see. So meaning, once we have finished the preparing software, it was taking 2 days here, we can straight away install the software. So it will be done the same week. So, but even if it's taking how many days, meaning we can see, so here we are ending on, this is the Monday, Tuesday, when it's up to Friday. So the installation of the software was taking what? It was taking 4 days, but it was done in week 3, okay? But it will be completed the other week but it will be done in week 3, okay? So after the prepare software, and then we can install the software in the same week, so week 3. But it will be to end here because it was taking 4 days. So meaning the Saturday and Sunday we are not working, okay? So Saturday and Sunday we are not working. So meaning it can end on Monday the other week, week 4, but it was in week 3. That's when it started. All right. Then we have to assemble computers. After you install the software, you assemble computers. So as we assemble computers, this will be done in week 4, assembling, and it was taking 7 days. Okay, so we can see here. So assemble computers was taking 7 days. So meaning we can go this way. We can take the 4 days there because Saturday and Sunday we are not working. And then what goes on is that it will be completed the other week, but we are supposed to say week 4, but we assemble computers, okay? It's week 4, but it will be completed the other week. But we're just talking about the week in which that will be done. All right, so now connect computers. Connect computers can only be done after we assemble computers, can connect them. So here, after this one has been completed, that's when you can connect the computers here. So it was taking what? So we have to check. So it's done in week 5. Connect computers will be done in week 5. And then how many days? 3 days. Okay. So we can now check where this one completed. It was taking 3 days. So it will be completed the other week, which is week 6, but it started in week 5. All right. Then we go for pilot test and refine system. This one is automatically in week 6 because this one is completing here at this point. Okay, it was completed on Monday, the other week, which is week 6. All right. So now pilot test and refine system, it's in week 6 automatically. So here week 6 here. Okay. Then it was taking two days. So meaning 2 days is just within here, within the week. Okay, so it's ending there. And then we can now start up the system and inaugurate and hand over to client. So it is just done within the same week, which is because it's only taking 1 day. So it's just that. So in short, we are saying we are taking 39 days for us to finish working on this project. So this is how we are going to calculate, how we calculated the missing, coming up with a Gantt chart. Is that clear so far?
Just a question here.
Yes.
Okay, it's clear on what you have done here, but following the, is there any way of finding the number of weeks? Isn't there a formula of doing that? Because I'm asking this because the document I received, it's showing how they used the formula to calculate the number of weeks, but then the weeks that you are finding here are totally different from the ones I have. So I don't know if there's a way of finding the number of weeks using the formula.
No, the formula that was sent to you, you can ignore it. Just go this way that I've gone, because we are just building up based on what we have started. That's why they only gave what the starting activity, meaning this activity A was just a starting activity. Then these other activities we are just following based on the starting activity. So that calculation is not supposed to be considered. We only consider the same way that this has been done. Even in other questions for the Gantt chart, this is the way it's supposed to be done. So you should ignore that other way of, there's no formula here. The only formula that you need to know is the formula when calculating the PET, in the PET diagram, the initial part that I explained for the expected time. But this one, it's an aggregate. You start aggregating. So that's why they only gave us the starting activity, the 5 days. So the other ones we just follow after. Which one? After the activity.
All right, noted.
Okay. So part A and part B, they have been completed, they have been done. Even part C has been done because they say indicate the completed and planned activity on the chart. So from there, the examiner is able to see in this which activity is actually being completed. So you can see this activity A for designing the system is completed in how many days? 5 days. In part B is completed in how many days? So you can say part B is completed in 10 days time. So you can be actually stating in how many days are we completing purchase of the components. So in 10 days time, we can finish purchasing of the components. And then configure network, it's completed in 12 days. After 12 days, or within 12 days, you can just say within 12 days, we are able to configure network. And then prepare software within 16 days. And then install software within 19 days. That can be done, or just within 22 days where it's actually ending. So we're talking about the completed, in which time, because you're saying indicate the completed and planned activity. Okay, so you can look at what time are we completing each of these activities. All right, so assemble computers, we can say 31 days. Then the total completion time for our project here is within 39 days. We are able to finish up all these activities, starting from designing system, getting down to startup system, then inaugurate and hand over to client. All right, then the other part of shortcoming for the Gantt chart, this one is a theoretical part where this one, I think that has been explained. So you look at the, okay,
Hello?
yes, please.
Just a quick one before you go to in the weeks. There are those that are overlapping. Which one do we pick? When the week started or when they ended? What is the tradition of that one?
Okay, so here we are design system on the computer. We are just within 1 week. Okay, so we have within 1 week we can see within the week. Okay, so you can indicate the week, like design the system on the computer is in week 1. All right, they need purchase components and configure networks. If you're supposed to put in weeks, you can say these are done in week 2. They can be completed in week 2. They need the configure network is completed in week 3. Same as the other one here, but now this other one for install software is completed in week 4, but it started in week 3, but completed in week 4. So you can say for design system on the computer, it's completed within week 1. Then purchase components completed week 2. Then the configure network is completed also in week 2. Prepare software, it is completed in week 3. Install software is completed in week 4, but started in week 3. Then assemble computers started in week 4, but completed in week 5. Then we get into connect computers, started in week 5, but ended in week 6. Then pilot test and refine system is just completed in week 6. Then as we set up system, just completed in week 6. Is that okay?
Yeah, thank you.
So this is how you're supposed to indicate the starting point and the ending point of each of these activities. I think this is clear, unless there are other questions. I think we can end here for now, unless there are other questions.
Yes, I have a question.
Yes.
I heard you say, so this work was completed in 39 days. But then my question is, we are excluding Saturdays and Sundays. How are we counting it? how it's from the look of things, like we are counting them at the end of the period.
Okay, so in short,
Because
what we're trying to say is, if we are to go by weeks, here it's open. Here on top there, we're talking about days, then we're also talking about weeks. So in short, we can just say within 6 weeks, we're able to complete all these activities. Because the startup system, when you integrate and hand over to client, is done in week 6. So this is the end point, the ending week in which we are finishing all the project activities. So to go by weeks, we can say in week 6, we're able to finish up working on the core activities that are listed here.
All right, thanks.
Okay.
Okay, so I will. The other part is theoretical part. Those of you who I sent the first copy,